Hello, my friends. Today I'm going to talk about how we can handle um, power, how we can calculate power using the phasor relations. So now, let's say we have a device, right? The impedance of the device is Z, and you have a current going in. The instantaneous current is I of t, and the voltage here is so-called V of t. Uh, so by Ohm's law, you will know um, uh, V by Ohm's law. Uh, V is always equals to Vt divided by It. So all these are very easy to understand. Now, how about the power? The instantaneous power, instantaneous power is going to be PT, yeah, P of T, which is Vt times It. Um, but this power is not very much of use. Um, Instead, there's another definition which is more constantly used: average power. The average power, by definition, is uh, is equals to uh, the sum of the instantaneous power over one period, and the total value is going to be divided by one period, where T is the period. Now, in this case, we have the formula here. Now, suppose Vt is a value, right? V max times cos omega t plus say alpha, yeah. So this is the the voltage expression in time domain. And how about the column? The column will be like this: I max and then cos omega t plus say beta in this case. So in a phasor diagram, you have an imaginary number here, and you have a real number here. So you will expect, right, V to be some angle, and this angle here is alpha, and the current here may be like this. beta. So the phase difference here will be alpha minus beta. And now if we do the calculation, if we substitute the VT, IT into this expression, then what we are going to get is 1 over T0, and then Vmax, Imax, and then Imax cos omega t plus beta and dt. And this expression is a bit very complicated, but it doesn't matter. We can handle it. So we know that cos A cos B is actually equal to half cos A plus B plus cos A minus B. So we use this formula to evaluate this integral. And we don't have enough space here. But we can still make it, huh? We can still make it. So let's erase this diagram, right? We should be able to handle it. Now, if this is true, right, we can simply say 1 over T P average, and then we have V max and I max here. And A plus B, right? Cos 2 omega t plus alpha plus beta. And then another function, cos alpha minus beta. And then dt. So we have this expression here. And it's much easier to handle. Because this term is a sinusoidal term, and it's a periodic term, so the integral of any periodic term will be 0. So this one is going to be 0. So the only term that is left is this term, which is independent of omega t. So now we can for sure find the value here. 1 over this guy, right? We will end up with T and V max, I max, and then here we will have cos alpha image, yeah, alpha minus beta. And here, right, we also need to multiply by T divided by 2. So obviously, at the end, the expression here is that simple. the T is got cancel off with each other. So this is the final expression of this integral. So in other words, when you integrate, when you find the average power of IT times VT, right? Then what we are going to get is um, the maximum value of V times maximum value of I divided by 2, and then multiplied by the the phase difference between voltage and current, cosine of the phase difference between the voltage and current. So this is what we are going to get. Now, having said that, uh, we found the power. So um, in electrical engineering, uh, the engineers try to simplify the procedure instead of going through all this analysis. He just assumed that uh, we have two values here. The amount of power is going to be, let's say, I don't have enough space here, so I'm going to erase the space here. So I'm going to write down the value here. So let's write down the um, important value here. E max and I max divided by 2, and then cos alpha and as beta. So this is the value of power. Now, the engineers the engineers had come up with another variable to replace this expression instead. So they have this one and I max divided by root 2. So they call this value root mean square. Root mean square of the power. So whenever we use phasor analysis, we should use the root mean square value. Now, and if we use right now, we have already known that the VT is going to be VT is the max, and then omega t plus alpha. We have already defined it, and IT is going to be I max, and then cos omega t plus alpha. And we have already learned that in order to turn this expression into complex domain and express them in phasor, then what we need to do is say we define another variable, say v. and then the RMS value, V RMS, and then here will be a exponential of alpha. Uh, and by the same token, the phasor for I is going to be IMS, RMS, and then the beta. So these two variables, V and I, are complex value, complex complex. Now, what we are going to do is to, instead of using this complicated formula, right, do we have any way to calculate the power using phasor, using complex number? The answer is yes. What we need to do is, right, P average is actually equals to V, right, the complex number, and then I conjugate. Or equally, you can write this V conjugate and then times I. If you want a proof, right, I can also give you the proof. Uh, uh, right now, you have the value here. I can show you if we use VI to calculate it, right? Then what you need is just VRMS times alpha, and then IRMS beta, and do not forget that we need the conjugate. So the conjugate of this term is equals to be yeah, I apologize. I had to say this. The view value of this expression. So real, so this is the power, or the view value of conjugate of V times I. So both formula will give you the power. And I'm now trying to prove it to you. And now, and this guy is going to be minus. So eventually, what you get end up with is uh, um, alpha minus beta. So indeed, if we take the real part, did I make any mistake? Take the real part. Yeah, I think it's right on. If we take the real part of this, yeah, indeed, what we are going to get is cos alpha minus. So we got it right, right? So if you use this formula, we will find the power, right? This is uh, the formula in phasor form for power. Now, you have this and this, right? That's okay. Now, I think you believe that, right? You have the formula here, which is good. But then the we also want to if we can end up with any formula for power. which involve Z. That's okay. It's very not difficult. Now we have already got this formula here, and now we know that V over T over IT is equal to Z. You know that? So now these guys can be expressed as um, uh, and this guy, right? So we can write this is Z equals to. Sorry, I shouldn't say that. This is particular. We shouldn't use time domain. Uh, Z is a complex value, right? So we have to use phasor. Yeah. So this is what we are going to, what we can get. Uh, we know that, yeah. Now, the power is equals to uh, say this value. Now, what we can do is here, we can say this I equals to V divided by Z. Now, we substitute the I into this expression and see what is going on. P average, and then V, and then V, and then uh, divided by Z. So hang on a minute, right? V star divided by quantity of V times V. And this one, we know that it is a absolute value square. So this is another formula for power. And equally, we can also do this, right? We can use this half I V times I, and this guy here, the V here is actually IZ. So by the same token, right, we can also get the same value. So the magnitude square times the real part of the impedance will end up with power. By the same token, the magnitude of the voltage square divided by the um, real power of 1 over Z will also end up with the average power. Okay, so I'm going to highlight what we have learned. First, we have learned this expression, learned this formula. Secondly, we have learned this. These are very important formula, right? And the final one is here. And also here. So all these parameters, all these formulas are very useful for handling power calculation. If you have any question, please feel free to leave your question in the comments box underneath the video. Thank you very, very much for your support.